Introducing polynomials. A polynomial is an expression that consists of the sum of terms of the same variable with different positive integer powers and a constant term. Examples of polynomial expressions include x squared minus 5x plus 6, this is a quadratic polynomial, 1 minus 2x, this is a linear polynomial, 0, we give that a special name called the zero polynomial, x to the power of 5, so this is a polynomial that consists of one term, and the constant term in this polynomial is 0, but because it's 0, we don't show it. 3x to the power of 4 minus 2x cubed plus x squared minus 5x plus the square root of 2. This is the polynomial that has an irrational constant term. And a squared plus the square root of 3 times a minus 1. So this is the polynomial where the coefficient of a is irrational, and that's okay. And the variable is not x, but a. As long as it's the same variable, then that's okay. We can use any variable we like. But the variable x tends to be the one most commonly used. Now, examples of non-polynomial expressions. X squared plus the square root of x plus 1. Now this one breaks the definition here, different positive integer powers. Now square root of x is a positive power or a positive index, but it's not an integer one. So square root of x is x to the power of half, so that breaks the definition. X minus 1 over x, okay, is also not a polynomial. X is okay, that's fine, that's x to the power of 1. But 1 over x, that's x to the power of negative 1. Again, it breaks this definition that it needs to be a different positive integer power. This is an integer power, but it's x to the power of negative 1. It's not positive, so therefore it's not a polynomial. And x cubed minus 3x squared plus the sine of x, x itself cannot be the input to another function. In other words, it can't be part of a composite function like sine of x or log of x or anything like that. So the x can be raised to a power and it can be multiplied by a constant coefficient. That's all that's allowed with a polynomial. Now, the natural domain of a polynomial is all real x. So in fact, if you go to the examples of the non-polynomial expressions, two of them, so x squared plus square root of x plus 1, the natural domain is not all real x. In fact, for the first one, x can only be 0 or positive. And for the second one, x minus 1 over x, x cannot be 0. So it's not all real x. Although for the third example, it is all real x, but x is, one of the terms is a composite function where x is part of, or sort of the input of another function, therefore also not a polynomial. Now more formally, a polynomial is an expression of the form an, so this is called a subscript, an x to the n, x to the power of n plus an minus 1 times x to the power of n minus 1, and an minus 2 times x to the power of n minus 2, and so on, right down to a2 times x to the power of 2 plus a1, x to the power of 1 plus a0, and there's our constant term, where the coefficients, so this is a0, a1, dot, 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 all the way to an, are constants, and n is a non-negative integer. So these powers here are non-negative integers.